with a lot of explanation. This is new material that I'm trying to get into, something called active learning. This is for in machine learning, you're trying to train something. Let's make this a little bigger. So we train things called models, like a classifier. And so a classifier is something that detects or tries to estimate whether an object is in one class or another. So, but it does it only from data. So you could think of this, it's like so the example we're going to use today is trying to guess the sex of a person or from their birth certificate first name. So the sex on a birth certificate, and we're going to use that as just the toy example. Some other examples of classifiers might be like disambiguation of words, like say the word interest. In natural language processing, we often want to know which meaning of a word might be being used by somebody who's spoken a sentence, especially a chatbot. So you might want to know whether they were using the word interest to talk about financial stuff or they were talking about their personal interest or whatever. And so that's called disambiguation. And so you can use natural language processing models to classify which of the definitions of interest the user is talking about. So that's what a classifier is. Logistic regression is a really common one. It's just like your linear regression. It just only has zeros and ones coming out of it. So it chooses it chooses discrete classes. So for this active learning thing, the goal is to incrementally improve the model without having to have a bunch of examples to train it. So you can imagine how many examples of sentences and usages of words if you're going to try to train a classifier to recognize all the different possible definitions that are in a dictionary and for all the different words that are in the English language. So millions of possible meanings of tens of thousands of possible words. And so if you had to go in there and label all that, with the dictionary it'd be easy because you could just, if you could electronically, if you had that in a structured data set. But for in most cases, it's not. In fact, even in that case, it's not. Come to think of it. But anyway, I'm rambling. So you have a training set. So you have some number of examples, and so let's say you only have a few examples. Like you have a sentence like the interest rate today was X, and then you've got another one that says my personal interest is Y or whatever. And so you've got a training set with just a few examples that you've labeled as their appropriate definitions, or you've got a few names that you've labeled according to the birth certificates. And so you can start out with just a few of those, and then you add some sort of an anomaly detector to see. Well, I'll actually, this will make more sense once I actually get into the actual algorithm. So it's actually it's a lot simpler than it sounds. There's only 6 steps in the algorithm, and so you basically continue the loop until you're done. So until you've got a decent model. So the first thing you do is you take those few examples that you've got and you fit your classifier to that training set. And then you evaluate how good that thing is. So this would be like you take it, humans do active learning when they're trying to learn a topic. Like say you're trying to memorize the meanings of some words in your vocabulary list. And so you'll give yourself a test on some subset of the overall examples that you were trained, and usually be a set of words maybe you weren't even trained on, or you didn't just anyway. So you check how good you did, and you score yourself on some sort of a test, and then you this is the tricky part. You want to see how difficult each one of those. So then you use that then you go through a bunch of examples that you've never labeled before. If you're practicing something, then you try your hand at a bunch of new words that you've never seen before. You don't know, you haven't read the definitions about, and you try your hand at them, and you estimate your confidence in each one of your answers to those. And the ones you got right, the ones you think you got right, you just assume that your model is doing well because it can tell you what the probability is. These models like logistic regression, and And so if the ones that you're really confident in, you don't worry about those. So you don't add those to, so this is I forgot to mention that this U represents some, I guess I didn't put that here. So we've got the, we're incrementally building up. This is an unlabeled data set. So we've got here in the U. So this is a pool of all the possible words. If you're trying to learn words, this is a pool of all the possible words in the English language that you could possibly be interested in, but they're not labeled with the definition. So you don't even know what the definition is. And so you have to have somebody go read the word, read the sentence, and decide what the right definition is. And so, so you don't want to tell somebody to label all the words. You just want to give them a few. And so you pick the few that were difficult for your model to answer. Just like when you're taking a test, you would only study those that you think you're probably not going to get right. And so that's what this is all about. This line of code here would take care of that. The next thing you'll do is so this is where you're selecting like the top 10 in this case, or the hardest 10, the most difficult 10. This is another refinement that people, I was just reading a paper where they this year came up with a better way than just looking at your confidence. You also look at kind of how close that example is to all the other examples in the dictionary. So like if you have a word that's really similar and has a lot of the same letters or a lot of the same syllables as other words in the dictionary, then you probably don't even want to worry about that one. If it's close to a lot of other words, one of your words that's already, so you avoid the words that are close to other words that you're getting confidence on. And so you're looking at both how uncertain you are and how dense the area is around you in this space of words. And then you need to split your data set into some that you're going to use for testing, some that you're going to use for training. You then extend your training set and you extend your validation set with those two different, after that split. And then you go back to the beginning and you do it all over again. So that's active learning. This is what it means in machine learning, and this is kind of what it means to a human, but it's for in the human context, a better way to think about it is, or another way to do active learning is you want to make mistakes. So machine learning models, they know how to make mistakes. You give them a bunch of examples and they will try. They'll give you an answer for what the label should be, but they'll often get it wrong, and they don't have any qualms about making mistakes. But humans tend to not enjoy making mistakes. So you'll often find yourself when you're writing Python code just not wanting to write something until you've looked it up online and figured out, okay, I need to copy and paste this code. It's much better, and you'll find that if you can do so, these models can do extremely well on very, very few examples, and they can learn very, very fast and very efficiently, like 10 or 20 times faster than they would if you did it the conventional way. And so you as a human can do that as well. You have a neural net in your head and you're doing the same thing the machine is doing. And so if you do the same sort of technique, you'll find it works well for you. So make a mistake, figure out how confident you were in the ones that, well, let's think about this. You can, well, with coding, it's a lot easier because you immediately know whether you got it right or not, whether it did what you wanted it to do. So the key is to just print out. It's often called debug by print. Print out what you try to predict in your mind what's going to output from your code, and then print it out and see if it did what you asked for. And then you're going to iterate on that. You're going to see how far away it was from what you wanted, and you're going to try to make a change and make another mistake that hopefully gets you closer to what you want. And you just keep making mistakes until you eventually don't make a mistake and it comes out right. So that's active learning in Python. I was going to show you an example where we actually went through this loop on that sex guessing, but you're going to have to save that for the book.